Hey y'all, Data Guy here. Since it seems like y'all like the Snowflake kind of application or real world use case videos, thought I'd make another one for you here on integrating the Tasty Bytes location recommendations ML model into a native data application. So what we're going to do is build an application that supports a fictitious food truck company, Tasty Bites, and its truck drivers to view the location recommendations provided by an ML model directly in a data application. So this is going to be fully built in Snowflake using Snowpark, so easy for Python users to actually leverage the Snowflake platform. It's going to use historical sales data and safe graph weather data from the Snowflake data marketplace to give more information to the model, so you don't have to go and find that information out yourself. So this is going to walk you through the whole step of building and then deploying. And if you want to look closer at the model, up to you. But I'm not going to. This is kind of more about building a how to integrate a model, ML model, and into an actual functional application, and not just have it sitting somewhere, having data scientists look at it. Because I like creating functional things, not things that are just cool. So without further ado, let's get into it. So first thing we're gonna do is in the home icon menu over here, go click on the marketplace and then search for Frostbite. So here, let's search for this. And then we're gonna wanna have is our safe graph Frostbite here. So this is just giving data to power location-based apps. So we're going to hit get. And then what we're going to do is rename our database to Frostbite Safe Graph. Make sure you're doing all caps. And then grant additional roles and make it public so anyone can use this. So now we have our data ready to use. We're going to go create a worksheet that is going to allow us to interact with this data. So here up on the top right, we're going to create a new SQL worksheet. And then we're going to do is have a long SQL script that's going to basically create all the data or get all the data from external S3 buckets where they're hosted and create places and schemas within our Snowflake account to actually model them. So here, use the account admin role, create or replace database Frostbite's HTML app, and just make sure I'm on AI warehouse. Create or replace schema Frostbite's Tastybytes ML raw, just creating different schemas, raw harmonized analytics, so the different kind of stages of our data, and then also creating a file format CSV. Always recommend creating your own CSV file format because the default one kind of sucks. And then we're also going to create an external stage pointing to S3. So this is just a public S3 bucket, quick starts S3 connection, where we're actually going to load some of our data from. So this is going to be raw ML data that we're going to load into our existing kind of Frostbite data here. Then we're going to create or replace table, in this case just create it, Frostbite Tastybyte ML app, raw shift sales, so just all the different sales from different locations and storing them in a table, and then creating a specific ML warehouse just for this specific application and setting it to use that. And then finally adjusting from S3 into that shift sales data. So taking that raw sales information from S3, bringing it into our created table, and then joining it in safe graph data. So just joining our spoofed sales data from that S3 bucket with the location data from this Frostbite safe graph. And then from basic on join on location, so just saying location ID, that's how we're going to use as the key to join these two sets of data. And then promoting the harmonized table from or to the analytics layer for data science development here. And then we're just going to have a view, so select shifts data. So now I'm going to run this all and cross my fingers that it's all going to work. And awesome. Here we have all of our different location data joined with our sales data. So it looks like we have some null values. We'll need to look into that. But here you can see the rest of it. We have our latitude, longitude, location name, how much sales, street name, day of the week, month, what shift it was. Let's see if we actually have yeah, okay. So there are some sales. It's just we're not actually making sales in a lot of these locations, which makes sense. It doesn't seem like Tasty Bites food truck can be in both Cairo and Seoul at the same time. So probably gonna need to trim this data downstream. But what we're going to do next is actually create a user using encryption. So what we're going to do here is switch over into local development. 1 second. And so to do this, this should be installed on your computer, especially if you're already using a Mac. Let me just fix my screen real quick so it doesn't just freak out on me. So now back in the Airflow UI, going to have a dedicated user for this application now. So SQL worksheet, and then what we'll do here is just copy and paste the statement again. Where here we're using our security admin role, creating a Tasty Bytes demo app role, then using our account admin role to just grant a bunch of permissions to this dedicated Tasty Bytes demo role. This is just granting it access to all different schemas and views we're using. Then using our user admin role and copying the contents of our Snowflake app.key.pub file. So copying over from VS Code, 1 second. And then going back into here, and I'm just going to paste it in here because I don't really care about the integrity of this demo account. So here, creating a user using this RSA public key, default role, default warehouse, must change password false, user security admin role, and then granting that role. So now we've got this all set up. We'll run all this, and I'll unpause once it's all done. And awesome, we're all set up with a user for our data application. So now what we can do is train and deploy our ML model. So to do this, what we're going to need to do is create another SQL worksheet. And then we're going to actually use SQL to train and run our ML model. And what's cool about these worksheets is that you're actually able to use both SQL and Python in them. So if I copy paste this, don't worry, we're going to go through this real slow. Here we are going to use the role account admin, use the database for Frosty Byte, use our analytics schema, use our Tasty ML warehouse. Then we're going to create a stage if it doesn't already exist. So it doesn't already exist. Surprise, surprise, app stage. And then we're creating a stored procedure. So stored procedures are basically like Python functions that you can define within Snowflake and then call later on. So here, build shift feature table returns a string. It's in the language of Python, so that's how we're able to write Python code within a SQL worksheet. Choose the runtime version, choose the packages, choose the handler, and then the handler is just the name for the function. So then saying as money, because I love money. Just kidding. So here, define create table, import our Snowpark functions, import just basically different ways that we can interact with Snowflake tables. So window is kind of just a way of saying, hey, you have a window into Snowflake from Snowpark. Then what we're doing here is creating a data frame from our shift sales, creating a rolling average. So you're just using regular Python, pandas work to actually create our rolling averages here. So partitioning it by location ID shift, ordering it by date, and then creating average location shift sales. So taking each location, looking over the past few dates of that location. As you might notice earlier, there was multiple entries for each city. That's for each date. And then partitioning it aggregating it by the average number of shift sales. Then what we're doing is, so imputing is just saying, hey, for every missing data, just fill it with fill any NAs with 0, and then encoding is just changing AM and PM into shifts, so 1 or 0, and then getting the dates, so getting the dates for tomorrow, filtering for just looking at our feature data frame. So for any dates that are tomorrow, drop those, we don't want to look at them yet. Getting location details, so here we're just adding different location details into location data frame. Then we're joining the location data frame with the feature data frame of our sales, and then saving that join table as the basically kind of clean sales information that has then the location information from Frostbite added alongside to it. And just returning a success. And then we're going to call the stored procedure that we just created to build that table. Then we're going to grant permissions to, again, our demo user to that table we just created. And then we're going to create a separate stored procedure. So I won't go through this again, but here the two additions we're adding are scikit-learn and job lib that allow us to actually access some more complex machine learning and AI tools that, I mean, I wouldn't say they're advanced for when you're using scikit-learn, but machine learning and AI tools. Then we're training this model, so importing functions, types, all the same stuff as before, creating a data frame, creating that rolling average, then creating average shift sales, a lot of the same stuff, getting the date, filter historical, drop. So this is dropping unnecessary data here, location ID, city, date, then splitting our data into our testing and training data set. So 80-20 split. normal split, same as my salary. And then importing packages, so importing linear regression and job loop.dump. And that's just going, and job loop.dump is just taking a Python object and just dumping it into a file. So here we've got our feature columns, month, day of the week, latitude, longitude, city population, shift sales, and the shift. And so our target column is shift sales. We want to find out, hey, how much can we expect each location to bring us in sales? Then we got our training data here. So bringing that training data that we just collated with this up here, bringing it into a pandas data frame, setting our inputs and outputs. So our inputs obviously are the target column, or are the columns we're going to use to inform our output. Then you just using a basic linear regression, looking at, hey, let's fit our feature columns and our target columns to that, saving that model, and then dumping the model into a temp directory so that we can then use that model later on. So here, return success, returning a trained model. So calling that, then, because we're fitting it here, this is where we're actually training the model, and then saving that trained model here. So now that we have a trained model to use, our next step is actually using that model to do some ML predictions. So here we are creating yet another function where we're going to have a bunch of different floats here, and these are just the different arguments that we want to bring in to actually, the data from the previous task, and returning a float. Language Python, runtime version, importing our saved model that we just saved up here. And so you can see that look .sav, and then packages, Cloud Pickle, Pandas, Cache Tools, and we're just adding these because they were in there before with the Snowpark package. We're not importing that all here. Now we're importing Pandas, Cache Tools, Vectorized, and here we're actually going to load the model from that import directory. So this is why we needed the cache tools, because it's going to need to access that cache data, in this case, that model that we saved earlier. And then Vectorized is going to take an input, which is that pandas data frame, load the model, get the predictions by feeding it our testing data set, getting predictions of that, and then returning those random predictions. And then finally, granting all privileges on a function to everything we just created to our dedicated user role. So now that we're done with that, we'll hit run all, and I'll pause and unpause when we're all done. And so now that we have this all set up, we actually have to create, so this all ran fine. I don't know why this just disappeared for me. The bottom, I think I just tried to minimize it and went snap down. But now we're going to actually just create a simple data application that's going to service all this data. So here we are actually just going to use the creator of this has a GitHub repository that is just going to actually build all this for us. So 1 second, I'm going to download that and start running it on VS Code. And for all new Node haters, don't worry, it is on Node. So, please, if you can't bear to see that, because I know I got a lot of hate on the Node video I made, just look away, I guess. So here, just using the CLI to actually clone this, and actually, I'm going to CD into desktop, data repos, and then use this. So this, 1 second. So that command was out of date. So you're going to want to use this repo clone and then the same exact thing. Well, almost the same exact thing. So here we have our new repo, which hopefully just didn't get installed in here. Awesome, it didn't. So then we're going to CD into integration. There we go. And so once we're in our little node directory here, we are then going to run npm install. So here, what this will do is just install any necessary packages and dependencies within Node. And then let me open it up in the UI as well, so you can see this kind of happen in real time. Video repos. And boop, boop, boop. There we go. Cool. So now open up terminal again. Hopefully this still ran. I'm not sure that it did. So after npm install is done running, then you're also going to want to go to your .environment file and copy and paste your private key. I'm just going to quickly scroll through that so you can. So here, just getting my Snowflake account identifier, Snowflake account, this public key footprint, I actually just got by going into Snowflake and running the following query. Make sure that you're not, so if you're following along with the instructions I'm going to put down below in the video, don't use the default name they give you because that one's not right. Use or describe this user because it's just a little bit incongruency within the guide there, but figure it out and now you don't have to yourself. So after we are done with that, let's go back into the fun stuff. So this is just reviewing. This is going to use key pair identification to actually authenticate us into Snowflake using the Snowflake API. So that's how we're able to bring the Snowflake data and then run it within this node application that we're using locally here. So what I'm going to do is go back into Snowflake. Let's get out of, you can see how all these different functions work. It's not really that interesting or the point of the video in my mind, but if you want to get into it, go for it. I don't really care. And so let's test this application, npx expo start, clear, and then we are going to let this start, allow it to accept incoming network connections, and then Metro waiting on, there's cache rebuilding, open the web browser, and now we are going to have this open the web browser in a second. One moment. So here, let's open up localhost and give me a second to play around with this and get it working. So whoever made this guide actually forgot to update it for the latest version of Node. So unfortunately, the last part that I wanted to show you isn't quite working right now, and I don't really know how to solve it. It's an issue with like one of the hash methods used not being supported anymore. But I still thought this is a cool kind of endpoint of, hey, you can take this data and integrate it into whatever you want. So here we have, our shift sales, we have which are predicted. We generated these predictions, remember before, using that whole script that we created earlier. So I didn't want to waste this whole all the work that we did at the end. But here you have kind of this table you can integrate, into any kind of dashboard and say, hey, let's look at the projected sales of, where we can put our trucks in Stockholm, Berlin. Looks like Berlin's making a ton of money. Let's start building way more Tasty Bites food trucks out there. So just kind of a cool, fun way of showing, how you can use ML in a really, real life and productive way. So despite the kind of a whimper of a finish, I hope you enjoyed this video. I hope you learned something. And above all else, I hope you have a great rest of your day. Data Guy out. Peace.